Prashant sir, please begin.
Okay. So very good afternoon to one and all present over here. So myself, Professor Prashant Sahatia from IT department DIT, and today we are here for one of the very best technology that is in software engineering. It's one portion of software engineering that is called software testing, right? So I'll give you the brief about the expert, and then we'll hand over the session to our expert. So, beginning with the introduction of the expert, he is Mr. Manas Trivedi. Currently, he is working as a software development engineer with Aplock, and he is experienced software analyst with hands-on experience on all levels of testing, including the performance, functional integration to system, and user acceptance. He is also skilled in Java, Selenium, JavaScript, Python, SQL, and Burp Suite. So, let us have some brief insight about the software testing from our expert. All over you, Manas. You can begin.
Sure. Thank you, Prashant. And thank you all for joining. Yeah, as Prashant already told, Manas, and currently I do have experience of about an overall experience of about 7 years in IT industry, and I have performed like testing of web apps, mobile apps, APIs, database, shell scripting, and Windows native application, which is the EXEs as we so call it. So today I'll be sharing a few fundamentals about the software testing, and like also at the end I'll be sharing a few demo about the software automation, how it is being done, and like the few mistakes, like usually we, or you can say the few myths that are there for software testing, right? And yeah, if you guys have any questions during the presentation, please go ahead and ask them. Right. All right. So let's get started with our presentation here. All right. So let's check the objectives for today. Okay. So first of all, we'll be starting with what and why of software testing. Then we'll move on to the scope of testing, or so-called the methodology of testing. Then we'll be covering the whens a testing needs to be performed for the effectiveness, because like at each stage of software development life cycle or software testing life cycle, we require a different kind of testing to be performed. Not every testing is same, right? So when the testing needs to be performed for its utmost effectiveness, then we'll move on to the 7 testing principles and the details about them, brief details. Then we'll cover what are the different types of testing, like between non-functional and functional, there are in-depths of it. So we'll cover that. Then we'll cover who performs this testing and who is responsible for overall quality of a software. And in the end, a short demonstration of automation testing, right? Okay, so let's move on to the first slide, which is what. What is software testing? I think all of you are familiar with the term software testing. Some know it as debugging, some know it as QA task or something. So to sum it up, I'll just write it in a one-liner, which is, it is a process of evaluating a software based upon given requirements. So now these requirements can be from anybody, from the business perspective, like a business leader or a software tester, or also a product owner. Anybody could give us the requirements. So this is just a process of evaluating software based upon a certain set of requirements. That's all. So now the question comes, why? Like, why we need the software testing, right? And there are several reasons of it. Some of them being to identify defects that we all know. Other is to reduce flaws in certain components of software or software as a whole. Because if we do the testing, then only we will know if there is an issue or not, right? So that's one thing. Another thing is making reliable softwares, producing softwares that we can actually rely and we can carry out our business task on it. Other things being gaining confidence in the software, because if we won't test it, we won't know if there is any flaws are there or not, right? So we need for that. Other thing is for cost effectiveness. The early we find a defect in the software testing lifecycle or software development lifecycle, the easier it becomes to eradicate it or resolve that issue. Unless it goes to the customer, and again we have to pull the build back, and then we have to perform the testing again and fix that again. So that's very much time consuming and also cost ineffective. So another thing being security, which is privacy as we call it now. So all of this included, it's almost everything about the customer satisfaction. So overall, we say why. Why we need software testing? It's because it brings quality to our software, right? So this was what and why of software. So now, how and what is the scope of testing? Like, how can we start the testing? What is the first step, and how do we implement? What are the different categories of testing and everything? So let's dive into that bit more. So scope of testing, and that's methodologies also called, right? So there are two scopes behind testing. One is functional, and the second one is non-functional, right? Functional is also called as black box testing, and non-functional is called white box testing. We have all known about the black box testing. It's like we don't know what's inside of it, and white box means that we know the implementation of the code of it. So let's see actually which kind of testing is being there in non-functional, functional, so-called black box and white box. This is the sequence of the testing. So these are all kind of testing that is being performed in the functional testing. Functional scope usually involves the user interface of the software. First of all, when we start the testing, obviously it is in the phase of the developer. It is in the hands of the developer. They do the first testing on the software. That being said, unit testing. Unit testing is testing the smallest piece of a code that can logically be isolated in a system. In most programming language, this is like a function, a method, or a property, which we can test individually without the dependency on any other unit. That is a smallest piece, so that's the unit testing. Now comes the component testing. That's the second phase, you can say, for the testing to be performed. So component testing is testing individual modules. These modules are consisting of logically grouped units. So these modules are isolated with other modules. That's why they are components. Usually component testing is being done after unit testing, just to know that all the units are performing correctly, and now we are moving on to the component testing. And once that is done, we move on to the integration testing, which is you can say a significant part of bringing the whole software together. So where all the modules, you can say the modules that we tested in the component testing, those are integrated, or you can say those are coming together, and we test them together logically. Instead of bringing illogical modules like something from WhatsApp, let's say, and something from Instagram, then it's not making sense, right? So it's like we bring the logical modules together and then we test them. So it's typically a software, right? Like it's a software testing technique which involves multiple software modules and could be coded by different programmers. It doesn't have to be coded by a single programmer. It could be by different programmers. And purpose of this level of testing is to expose defects in the integration between these modules. That is, the data communication between these modules is what we are targeting here in integration testing phase, right? And then once all this is performed in the integration testing, we create a report about the different integration, or we can say the different data communication that was there and the data communication that happened. Once that report is generated, that is the first three stages of, like, these three stages actually are being performed by the developer, or we can say some technical person who is having the knowledge about the programming language and also little bit knowledge about how the testing as a whole works. So these three first steps, like unit testing, component testing, and the integration one, These three are being performed by a technical guy, usually who is having the knowledge about the programming language. Okay, so then the system testing comes. It's also a black box testing technique which is performed to evaluate the complete system and complete system's compliance against the specified requirements. So in system testing, what we do is we have a notion of testing the whole end to end, from starting from one module to having all the modules integrated together. That's where the system testing comes. So then it's a simple question, right? Like why the developer can't do the system testing. The only reason behind it is if the developer knows how the units are implemented, components are implemented, and the integration of all these components are how it's done, then they will have a biasness about the inputs that they are giving and also how they are testing few things. They are not putting all of the information which would actually break those things. So that is a level of abstraction that we are creating. That's why system testing is different from unit testing, component and integration testing, because all of these three first phases is consisting. Like you can say, it's a part of system testing. So why system testing? Because why system testing is not given to developer? Because it creates an abstraction, and that's why we can get a proper feedback of a testing. So it's just used to measure the quality of the whole system. But with you can say a QA team or a tester or a proper tester, not by the user. So that's why it is system testing. Now comes the acceptance testing, which is the last phase of software testing. You can, but there are other phases, but acceptance testing is actually the last phase. It contains different modules, like different sections, subsections. Some DevOps do this acceptance testing in some organizations. There are business owners who do this acceptance testing. In some organizations, they release a beta, like as a beta version to the customers, and they do their acceptance testing, right? So acceptance testing, what it is, it's basically it's performed after the system testing, and it's used to understand how well the product is developed. It's for gaining the confidence on the product, and if there is any flaws in the product that was missed in all of the full four previous stages of the testing, then we check, like then we get the feedback from it in the acceptance testing phase. Do you have any questions, guys?
For now, no questions.
Okay, great. All right, so let's move on to the non-functional testing, that is white box testing. Generally, in the white box testing, we have the insights about what is there in the code which is being written. So basically, it's performed always by some technical person. Usually, there are tools which help non-technical people to do the non-functional testing, but again, they rely upon the technical guy who will have information about how the components were developed and how the logic was there. So that's the reason of having non-functional testing being done usually by the technical people. Okay, so first is security testing. What is security testing? I think you all know that the cyber crime that's been rising in whole decade recently, and also during this war situation with Russia and Ukraine, we are having so many cyber attacks. Not just those two countries, but whole world is undergoing through that. And also in the recent terms of event, like with China, we had some cyber war that was going on, and there were actually they targeted one of India's powerhouses and for breaking the chains and the sea courts and all such things. So this is one of the requirement of software to be tested on the security level. It's a type of white box testing, right, that uncovers the vulnerability, the threat, and the risk. The risk of software applications It's used to prevent attacks from the intruders, and the purpose of security testing is to identify all possible loopholes, right, and the weakness of the system, which might result in loss of revenue, loss of information. So that's the main purpose of having this security testing and also awareness about the security, because it could actually have our whole life in somebody else's control if we don't pay the attention to the security of the software. Because in usually our day-to-day lives, we perform mostly all the transactions, all the like notifications, or you can say all the updates, posts, and everything from one or the another software, like banking software, social media, or anything as such. Then traveling and booking our travel flights and all such things. So it's actually necessary to have all this information regulated and governed, like who is using our data. That's all because of the privacy concerns, right? So another thing is performance testing. Performance testing is usually not a kind of testing, I would say, because it's used to gain a perspective of our software, that where is the, we can say what is the standard of a software, like how well this software is performing, because that's not a bug, that's something we are putting it into our software as a feature, that it can perform such so and so task in like minimal or like 1 second or 2 seconds. Like just we just click and open it, and it will perform all this task in like one go. So that's one of the feature. It's not a bug, it's not a testing, but yeah, obviously, because we don't like any sluggish software, or any software which won't be responsive or crashes in low responsive, like if it is having no resources or low resources in the phone or application or website, and it crashes, nobody would like it, right? So this performance testing is a practice of evaluating how a software or a software as a whole performs in terms of responsiveness and stability under a particular workload, definitely. Because in normal situations, everything looks fine, seems fine, and everything works fine. But under a particular situation where there are certain number of users come up, and now the responsiveness of the software is reduced, then it doesn't make sense to work upon those software or use the software. Just like that happened in Facebook in October 2014, right? Like the big billion days come up, and all the users around the world are going to Flipkart for buying it. But due to some of the other reasons, because of the low responsiveness and also because of the low performance, the website was down, and there were happenings of many happenings of orders being cancelled and the refunds being issued after the orders were booked. So that was one of the, you can say, performance glitch of very e-commerce giant Flipkart. Right. Another thing from that is after the performance testing, the first thing that comes into non-functional testing is interoperability. What is interoperability? That is simple as the testing is being used to examine the software introduction, either or its components or a whole software, because we are trying to check one software how it is integrating with another software. A very good example of it would be we are booking a railway ticket through IRCTC and we are paying through Paytm. Then in this condition, we are having one software and how it is working with the another software, that is Paytm. So if this Paytm, once we do the purchase or make the payment, it doesn't send the information back to IRCTC app, then the ticket won't be booked, but our money would be deducted. So this is best example of interoperability, why we need that testing, and how the data is being exported from one application to another application, that is being performed or measured in interoperability. Another thing is portability, which is when during this testing, obviously we check how easy it is for our software to be moved from one environment to another environment. Usually we are having Dockers right now, containers, which will be helping us do this, because usually you have already seen, right, that many of us would be encountering this, that some things work perfectly fine on developers environment, but not on the QS environment or any of the client's environment or customer, for example, let's say. So that's one of the issue with the environment, right? But that kind of testing, like it should work everywhere in every environment, that is being performed in the portability testing, where we check the different environment variables, the configuration files, and how well they are configured and how well they are dynamic in nature, that they take the configuration from the system and it does not change the like regular behavior of the software. Instead of just making us change, it automatically changes itself. So that is usually in the portability testing. All right. So scalability. Scalability is just another type of performance testing, but it's usually that we scale our product in a way that how many users are simultaneously able to use it. So in this kind of testing, we just check, we just give a rank, or we just give a standard to our software that okay, 5,000 people simultaneously can use this banking site and perform their transactions, and none of the transactions will result into deadlocks or any of the policy. So this is just one of the type of performance testing, but yes, it's obviously very important in today's world, because obviously one thing, like for example, SaaS as a service, right? We use a software as a service, so there are so many people going to use it, and if we're not going to provide scalability to that, then people will result in deadlocks. There will be so many resources that's being used by one person, and another people will not be able to use it. So that's why the scalability is very important in non-functional testing. All right, so let's see when we require the software testing. So for the software testing to work perfectly and effectively, there are different phases of software testing that's been developed, and it also resides or resonates clearly with the software development lifecycle. Usually it's said that the same model of software development lifecycle is being copied to the same testing lifecycle, like software testing lifecycle. Because if we are having Agile as, for example, Agile as a software development lifecycle as DLC, then we will use the same Agile or the same model in the software testing lifecycle. So in that way, what does it mean is the testers will be involved early in the phase of testing, like early as in like in the requirement analysis phase. That's how the software testing lifecycle will integrate with the software development lifecycle. But again, when this like the testing needs to be performed and when it will be really effective, that actually depends upon which SDLC we are using. But still, there is one cycle of software development lifecycle and software testing lifecycle that goes along. So let's see what is the software testing lifecycle here. It consists of these 6 phases, right? In all the 6 phases, there are different tasks and there are different entry criteria and exit criteria for all of these tasks. So let's see the analysis requirements, which is also called the requirement analysis. In this phase, we evaluate or identify functional and non-functional requirements of a software. So you see guys, in this phase, all the non-technical people and all the technical people all will be together. They will be brainstorming regarding one or the other things, and they will be evaluating what are the different sections that could be included in the testing and what could be ignored for the current test cycle. So everything will be covered in the analysis requirement phase. And it also checks if the availability of automating the software test is there or not in this phase. So this is one of the phase in which we define all the parameters around the software. so that we don't miss out on anything and everything is clear as per it is promised to the customer. Then it is the test plan phase. In this, we create a test plan document, the strategy that it needs to be used, the tools and the roles and responsibilities of this participating, like all those who are participating in the test, are being defined. So after that, once the plan and everything is created, we move on to the test case development phase, in which we create the whole test case. Right? In this, we just create the test case and we make sure that all the test cases that we have created, they are transparent, efficient, and 100% effective. And also, it is providing 100% coverage. So the environment setup. After that, the another thing comes is the environment setup. Right? In this phase, what we do is we check all the configurable details about the environment and include different tools, which could be like covering like setting up the servers for testing. If we require any server which gives us the fake or staging replies or something, we create all the setups and all the servers which will give us the details about these things, which will be required in turn for executing the test. Then comes the test execution. Then comes the test execution. In this, we will execute all the test cases that we have written in the previous phases, and we will create a report, like what was the result of the test and how the test performed. And if there is any failure or something, we will create all this report and we will gather them. So that will be done in the test execution phase. Also, the test result is like covered here in the test execution. So that's where we will gather all the reports and create all the details, artifacts that is required for addressing the test. After that, we will have a test closure. That means the exit criteria of the whole test, like what was the requirement of the whole test to be done and did it perform it well or not. So in this phase, what we will do is we will create this report and we will give this feedback to all the other stakeholders how the performance of the software was. And upon that feedback, they will again, in the software development cycle, once they receive the feedback, they will again cover or start their defect analysis phase, or we can say again the software development phase, in which they will fix all these defects and they will again continue with the cycle. And again, we will cover up or come up with this whole cycle, which is analyzing the requirements, test plan, test case development, execution, and ending up with the test closure. So in this whole section, right, everywhere the software tester is involved. But in some cases, like for example, where there are non-technical people and technical people, so let's say automation and manual. So manual people are also there and they are like having all these test cases to run. So they won't be having, they won't be able to run the non-technical test cases, which will be, sorry, technical test cases, which will be covering automation part or such scripts, shell scripts or database testing. So in this, this is the time where we introduce the tools in the testing, which will automatically test all the requirements, test all the details. It will give us the results. It will give us the assertions. So in some point, in like all these phases, manual testers will always be there, but some point they will also be helped by the tools, which will be helpful for them in addressing all these test cases. Alright, so let's go and move over to, yeah, do we have any questions, guys?
We have two questions, Mohan.
Alright, that's good.
Yeah, just a minute.
Alright, so 7 testing principles. This is actually the base of starting with the testing, because obviously there are many myths about the software that we can perform the testing and it will always be fine if we perform the testing once, twice, thrice. And if we are not facing any issues, it's perfect, it's bulletproof. It's not like that. Basically, the software testing principles, the 7 testing principles, tells about what are and what should be our vision about the testing. It's not about how we perform the testing and all such things. It's already covered in the testing life cycle and the methodologies. This gives us the perspective about the outcome of the testing, and if there is any myth or if there is any misconception, this is used to resolve it. And if we need any other approach, this will help us in identifying the right approach for the testing. So let's get started. The first one, it shows the presence of the defects. Testing shows the presence of the defect. What does that mean? It means the role of the software is to make the software fail. Software testing is to make the software fail. So whole approach is to make the software fail. In this, what we do is reduces the present of effect. Once we do this, like once we do the testing, we understand that there is there's defects, but we are gonna reduce it. And obviously, once we do the testing or whenever we do the testing, we cannot ever cover the 100% coverage. Every time or any time, we will have some or the other things be excluded or ignored, or not if ignored intentionally, but it will miss out. So it's never possible to have like zero bugs in any software. It's actually not practical at all. Right, so this is the first principle, because it makes us sure that once we do the testing, there is going to be defects. If there is defects, that does not mean that have done the testing, but it just means that once we do the testing, there is going to be defects, and there is no other way around it. It can never happen that that a software is 100% bug free. Right. The other thing is exhaustive testing is impossible. It means the process of testing, right, of a software is mostly based upon inputs and preconditions, which means that there can be infinite number of values which we can provide to a software, but we cannot test with all those infinite values because it's not practical for a software to be tested upon infinite times, right? So exhaustive testing is impossible, meaning the software can never, like we can just test a software once, twice or thrice, but not for the infinite number of values. So not infinite test cases, just one test cases. So like also, if we provide the correct output and correct input, it could be possible it passed, but another time with that same, it could not be. So we cannot cover all the other possibilities, but yes, that's why it is said that exhaustive testing is impossible. We cannot do and check with all the different combinations. Early testing. The point that I briefed upon earlier, like in Agile, why we need early testing, because the earlier the tester is involved into the testing cycle, the earlier they will have less issues and the cost will be reduced, the time will be reduced, and the feedback will be given to the developer. So the development time will also be reduced with that. So, which is actually the best thing to do for reducing everything, like reducing cost, reducing the time, and reducing all the other like documents. Because once we build a defective software, we are going to push it to the customer, and once we get the result from there, it is very hard for the whole process to start again. So early testing, it's the best way of starting with the software testing and introducing a tester. Another thing is the defect clustering. The defect clustering means, for example, in a project, okay, there's a project, a small modules which is containing most of the defects, let's say. Now, if we find out that particular code which is having the most of the defects, then we will be able to find the similar kind of code in the other modules, or let's say other software which is developed by the same developer. The high chances are there that we'll be finding the same defect of the same code in the other module as well, or the other software as well, which was developed by the same developer. So that is called the defect clustering, in which once we get a source of like a root cause of a defect, we can identify the same issue in some other place, right? That is called defect clustering based upon behavior and location of the defect. The next thing is testing is contextual. It means that it is context dependent. it's easier to say like the testing approach depends upon the context of the software, develop different ways of software, and needs to perform different type of testing because the testing which is like we are seeing right up here, somebody else who is from a different level of the software development life cycle, he will have a different perspective of it, and the tester or any business developer or any other user, for let's say, they will have a different context of the testing. Like it depends upon like which kind of testing is being performed in let's say in uh, uh, in some real estate or let's say in some Paytm, let's say for example, in Paytm we have to check the minimal or even point or decimals, like what is the value of it, what is the Paytm balance of it, and all such things. So, but that is one requirement of Paytm, which is one of the wallet side. Simultaneously, if we have any other areas which is which is rounding up to the decimals of just zero, we don't require it because that's not the area what we are testing. We don't need that much expertise in there. So it's obviously it depends upon the context of the testing that is being performed. Then is the absence of errors policy. It means if your software or system is unusable, then it does not matter how many defects are found and fixed, it is still unusable. So in this sense, it is irrelevant how issues free or error free your system is. The usability is so poor that users are unable to navigate through the business requirement or carry out their task. So despite having few bugs, it's unusable. So that's basically we need to have the right requirements, and then we have to test it instead of just making it error free. Then the thing comes is the pesticide paradox. What does it mean? Is that basically running your test again and again and again in repetition excludes the possibility of not testing the other components or missing out on other inputs of the test case. So instead of running it again and again and again, we just need to change the methods or techniques or approaches that will be giving us the output about the testing, like about the test case. So that's another thing about the pesticide paradox. These are the 7 testing principles. All right, so let's move on to the different types of testing. Smoke testing, right? Smoke testing is usually for, let's say we have changed one area or one module, and that module is affecting other 3 modules. So we just need to check if, because of the change in one module, all the other 3 modules are working fine or not around that module. So that's called the smoke testing. In there is no right path to the testing. It's like you just know one thing affects other 3 things, and you need to check the other 3 things. That's called the smoke testing. Another one is regression testing. Most of us know it as like we have to test the whole software as a whole, but regression suits are being developed, in which what we do is we have a different set of tools through which we can identify the risk, identify the like whole section of area of change, and which area it is affecting, like which area it is affecting as a software, and all such things we are notifying, right? So in that we will note that the regression testing what we are having, regression suite that we are having, it covers the whole software and it covers the whole areas in which the defects were there previously, not now but previously, and we just notify or check it upon that there is no more defects into it, even though there is another modules introduced, there is new feature introduced or anything as such. So that's where the regression testing comes. Sanity testing, exploratory testing, API testing. So these all are just the type of testing in which we check different areas in which the changes were being made and how to cover those changes. In sanity testing, we just check the same thing. Whatever the details were there, they are having, like for example, we changed one module and it is affecting something. Now we need to stop that thing from affecting it. We perform the sanity testing. If there is any, like we know the fallback procedure or something, we perform the sanity testing and like make it to the very nearest checkpoint. In exploratory testing, there is no brief plan about the testing. Everybody tests upon their expertise. And in API testing, we test the APIs. Gray box testing, yes, guys. So this one is the mixture of black box testing and white box testing, in which the tester knows about some things or some components, as in how the logic was implemented and all those things, and most of the part they don't know about how it is being developed. So it is the black box testing and white box testing in mixture. Then comes the negative testing, in which we try to break the system and verify if it is working correctly or not. Let's say, for example, we are making some payment through any payment site and we are entering -10, then it should not allow us. It should ask us to enter some positive value. That's called the negative testing. If that passes, then actually the product is failing. This test is passing, so it's a negative testing. Alright, so now the real question is, who performs the testing? Like, there are so many different stakeholders who are involved in the software development life cycle, who are involved in software testing life cycles. Who performs these testings? Test analysts. Yes, they are the one who creates the test plan. So they are the one who also create the risk analysis documents. So they are the one who comes in the testing picture. Another one is automation developers. They create the automation scripts. Product developers, yes, they perform the unit testing and integration testing, component testing, like the initial part of the testing. So obviously the product developers, then the quality analysts, who are the actual testers of the product, or just you can say manual testers. Then the project owners, who are assigned with that module and they are carrying out the testing onto it. That's another phase of user acceptance testing, that is UAT or acceptance testing. The DevOps engineer, that is also part of UAT or acceptance testing. Business analyst, yes. So once the product as a whole is developed and they are ready to give to the client, before that the business analyst or product owner, so all they perform the UAT, that is user acceptance testing. SOC analyst, they are security analysts. They used to break the system in terms of network or security terms. Penetration testers, they used to break the system with security aspects, like in different level of the OSI models, they try to break the system. So this is usually for a product, and the SOC analyst usually works upon the architecture of that product. So yeah, these two are also non-functional testers, but yes, they do contribute in the testing. But are these all, guys? I think all this, or all of the person who are involved in the software testing lifecycle do plays an important role in the software testing process. So it's not only these people, but all of them, whoever is involved, directly or indirectly. Their opinion matters, or their feedback to the developers or the implementation specialist does matter. So yes, guys, everything in this section that I mentioned, apart from that, all those who are there does matter their opinions. All right, so let's see about some example. Okay, let's see a live demonstration of automation. Can you see the screen, guys? Hello,
Yes, ma'am.
Shank?
Yes, yes, ma'am.
All right. Okay. All right. So I'll just share a quick demo of how the testing of like one website works. Not the testing actually. We are just asserting upon to basic terms. But let me show how it is performing, like how the automation works. Like I'm not touching anything, but it will automatically calculate all the parameters and it will do the testing. All right. Yeah, this test is basically for LinkedIn. It will just go and search for a user. It scrolled down, it clicked on it, and it opened the profile. So here it passed. Let me show you. Yeah. So here I just had checked if the title was correct or not, and I have given these terms as variables. So likewise, this is just one example where we can give the inputs to the computer or website or web browser in which it will give us the output and let us know if there is any errors or the expected output was not made or not checked. So this is basically just a very brief about the introduction, or you can say very basic thing about automation, because there are different elements to it, which includes, for example, which includes. Let me show you one implementation file. Right. So see, this was one implementation file where I have written the logic and it will work according to all the logics that I've written. So we can modularize this, we can change the elements, and the test will run accordingly to the elements or the parameters that we have given. For example, in this one. So this is just very brief about the automation one. Um, yeah. So do you have any questions, guys?
Manas, we have one question.
Sure.
Okay. So the question is like how does machine learning will help in automation tools? Does machine learning helps in this?
Sorry,
I'm asking that does machine learning helps in software testing?
I am not able to hear you. Can you type? I guess
Okay.
in the chat
Just
or
a
something. Oh, yes, yes. So, with machine learning, what we can do is uh, we can include some patterns which would help in identifying the identifiers of, let's say, the elements. Right? That's where it will be useful, I guess, because we cannot say or like have the machine learn about what to implement, but we can definitely have something. We can say not something, but we can have the machine take care of the elements. So that is actually the identifiers behind like uniquely identifying which element to click upon. So for example, I'm just showing you one thing. Let's say I'm opening this is a website, right? I'm opening this. Yeah, so here what happens is, like in some conditions or some programming language that is React Native that I am recently working in. So in that, what happens is the elements identifications will be changed, the XPaths will be changed. That is the main soul of the whole automation testing. So what does that mean is, in this the ID, this one, the whole thing, whole page, right? Let's ignore that. Let's just say this apply now button, right? So in this we are having this id as this class h2 text pink, but it's certain what happens is this class will change. This is dynamic class. We cannot rely upon this class to always uniquely identify this element. So that's why we can have the machine learning to know what kind of change has been made, because obviously it is same, but it is always different. Like it is always in the subset of 1 2 3 4. Like in h2 it could be h3 h4 h5 or something. So for machine learning we can have this as like what is the reason behind this is changing and how many subsets are changing. So obviously with machine learning the machine could automatically identify what the change was made and again identify this element uniquely. We don't have to go every time and change this element into our test, because all the tests that we are writing will need to have one XPath element which will uniquely able to identify that element in the HTML. So yeah, I think if we focus more or check more or research more, we will be able to get to that point that automatically we can identify that element. Anything else, guys?
I have pasted one question, honest, in the chat box.
Sorry, checkbox.
Yeah.
What with that? Oh, okay. No, not testers. There are different, we can say, different professionals who are working upon this, but they are usually for identifying anomalies in the data sets and identifying if there is any wrong input that is being delivered or something like that. So for that only, but not for the software testers. It's we can say a different professional as a whole.
Okay. Okay.
All right.
So are we done?
Sorry.
Are we done?
That's all.
That's all from your side. Your end.
Yep, that's all.
Okay. 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 So yeah, thank you very much, Manas, for providing such informative session. And actually, I was also personally interested because my PhD topic is in software testing. So I was personally having the interest in this session. So
Okay.
thank you once again on the behalf of our university, and we'll look in the future for more such sessions. Thank you, Manas.
No problem. Thanks, Ishan. Thank you, guys.
Yeah, bye.
Have a nice day. Bye bye.